Section 6.3, Factoring Special Products. Because you're in intermediate algebra, we have assumed that you know some of the factoring already. We're going to learn two new factoring, which is a difference of cubes and a sum of cubes, but all the other factoring that I talk about here should actually be previous knowledge. If it's not, let me know and we can go over some more examples. So, in 6.3, we have, in a sense, four ways we're going to look to factor. Number one, we always look for GCF first. GCF stands for greatest common factor. So always look for greatest common factor, no matter if you have 2 terms, 3 terms, or 4 terms. So number two, after you've looked for greatest common factor, you're going to decide if you have 2 terms, 3 terms, or 4 terms. If you have 2 terms, you're going to follow the suggestions in number 2, which are either difference of squares. Difference of squares is a squared minus b squared, would factor into a plus b and a minus b. The difference of cubes, a cubed minus b cubed, this would be one of the new ones that we're learning in intermediate algebra. You do have to memorize this formula or you will not know how to factor, so make sure you memorize this formula. A cubed minus b cubed equals, in parentheses, a minus b, and the next parentheses, a squared plus ab plus b squared. Now the sum of the cubes looks a lot like that, but the signs are a little switched. So a cubed plus b cubed is going to equal a plus b, then in parentheses a squared minus ab plus b squared. So I just want you to notice what started off. With the difference of cubes, you had a subtraction sign, and then you start off with a subtraction sign, and then the next sign is positive. In the sum of the cubes, you have a plus sign, then you have another plus sign, and then a minus sign. So I want you to kind of think about soap. You have the same sign when you start off, that's the S, then you have the O for the opposite sign, and then AP is always positive. So let's look at this. Same sign, opposite sign, and then always positive. In the difference of cubes, you have the same sign starting off, which is the minus, then you have the opposite sign, so it's a plus, and then the last one is always positive. In the sum of cubes, you have a cubed plus b cubed, so you're going to start off with the same sign, a plus b, then you're going to have the opposite sign, it's going to turn into a minus, and the last one is always going to be positive. So make sure you memorize these formulas. If you don't have these memorized, there's no way to get the right answer. So please memorize these formulas. Now, that's if you have 2 terms. If you have 3 terms, your choices are either what we call the C method, the AC method, or perfect squares. C method. What is the C method? If your number in front of x squared, if the leading coefficient is 1, then we say it's the C method, which is the fast track method, the quick way. And it's going to equal x blank, and in the next parentheses, x blank. And how do we fill in the blanks? We find the factors of C that add up to B. So you want to know the factors of C, what are you going to multiply to get C, that add to get B. So you got to be very careful with your signs. Whatever those factors are that add up to B, that's what you put in your blanks. So that's why we call it the quick way. The AC method is the one that takes a lot of work. What's AC method? When the number in front of x squared is not 1. That's called your AC method. You have to worry about A and C, so there's lots of work involved. The last option you have if you have 3 terms is perfect squares. A squared plus 2ab plus b squared factors into a plus b quantity squared. Or a squared minus 2ab plus b squared factors into a minus b quantity squared. That you don't have to memorize the formulas. You could do the C or the AC method, but if you see that it's a perfect square, you can get to your answer a little bit faster. So if you have 3 terms, you either have the C method to try, the AC method, or perfect squares. Number 4, if you have 4 terms, your only choice is to factor by grouping. So again, the first thing you always want to look for is a GCF, the greatest common factor. Then you'd have to decide if you have 2 terms, 3 terms, or 4 terms. If you have 2 terms, look at difference of squares, difference of cubes, or sum of cubes. If you have 3 terms, look to see if it's the C method, the AC method, or perfect squares. And if you have 4 terms, you automatically know that it's factoring by grouping. So we're going to do quite a few examples, and I'm going to go through how many terms do we have, which one should it fall under, and let me know if you have any questions. Factor completely. Number 1, x squared plus 10x plus 25. So I suggest you have that first page where you filled out all the different options in front of you as we go through this. On number 1, we have 3 terms, so it's either the C method, the AC method, or perfect squares. If we look in front of the x squared, we see that the leading coefficient is 1, so this would just be the C method. Now, how do we do the C method? Well, we can almost jump to our answers. It's like x blank and x blank. Now, how do we figure out how to fill in those blanks? Well, you look for C, and C is the last number, so C is 25. You want the factors of 25 that add up to a positive 10. So the factors of 25 are 1 and 25 and 5 and 5. Well, 5 times 5 is 25, and 5 plus 5 would give me 10. So I can see that what I'm going to fill in my blanks with is a plus 5 and a plus 5. So my answer is x plus 5 times x plus 5. So that was actually a perfect square, because we could write that as x plus 5 quantity squared. Either way is fine with me. If you see that it was a perfect square, you could have jumped to your answer a little bit faster. If not, show the work and get to the answer just the same. So looking at number 2, we have x cubed plus 4x squared minus 9x minus 36. First things we always look for is a GCF. There's nothing in common in all 4 terms. Now, we just said we had 4 terms, so if we have 4 terms, we factor by grouping. And how do we group? We group the first 2 and pull out what's in common, and then we group the second 2 and we pull out what's in common. With the x cubed plus 4x squared, there's an x squared in common, so I'll pull out an x squared, and in parentheses I write what's left. From x cubed, I'm left with an x when I pull out an x squared, plus a 4 when I pull out an x squared. So I have x squared parentheses x plus 4. Minus. Now what's in common between a 9 and a 36 is a 9. So I'll pull out a 9, and in parentheses I'll write what's left. From a negative 9x, if I pull out a negative 9, I'm left with a positive x. Now be careful here. You took out a negative 9, so from a negative 36, you're left with a positive 4. So make sure when you pull out that sign, if it's a subtraction, all your signs are going to have to change. Now, one thing you can always check to make sure of is, in this class, if what's in parentheses is not the same, you know you've done something wrong. If there's a sign switched, if the x's aren't the same or the number's not the same, you definitely have done something wrong, so go back and find your mistake. But in this example, we see that x plus 4 is the same in parentheses, so that's considered the GCF. So I'm going to pull out the x plus 4, and what's left is, it's in parentheses, is the x squared minus 9. So I'm left with x minus 4 times x squared minus 9. The x plus 4 is done. We can't go any farther with that. But look at the x squared minus 9. It's a binomial. We have 2 terms, so we actually have a difference of squares. X squared minus 9 would factor into x plus 3 and x minus 3. So you're going to see in this section that factoring one time doesn't always get you to your final answer. You might have to do a couple of factorings. Number 3. We have 81x squared minus 49y squared. First thing we look for is to see if there's a GCF. Nothing in common. Now we look to see how many terms we have. We have 2 terms, so it's either difference of squares, difference of cubes, or sum of cubes. This is a difference of squares because we know 81 comes from 9 and 49 comes from 7. So don't forget about the variable as well. 81x squared would come from a 9x because 9x times 9x is 81x squared. 49y squared comes from a 7y because 7y times 7y is 49y squared. So let's write the formula. A squared minus b squared would factor into a minus b and a plus b. So what I've written below, the 9x and the 7y, are my a and my b. So it's going to be a 9x minus 7y and a 9x plus 7y. On the previous page, I had the positive 1 first and the negative 1 second. On this one, I have the negative 1 first and the positive 1 second. I did that on purpose to show you that order does not matter. Just one has to be positive and one has to be negative. So make sure you have opposite signs. So number 4 is a cubed minus 64. We have two terms, there is no GCF, and we see we have a cube. So that would lead us to a difference of cubes. Difference because we have subtraction. So let's write the formula. For an a cubed minus b cubed, we have to start off with a minus b, then we take a and square it, we add a plus b, and then we take b and square it. So what are my a and my b? It's what's being cubed. So what's being cubed to give me an a cubed is an a, because a times a times a is a cubed. Now what's being cubed to give me a 64? Not 8, because 8 times 8 is 64. I need to multiply the same number 3 times and get 64. So it should be a 4, because 4 times 4 times 4 is 64. So that'll be my a and my b. So following the formula, a is just a, and b is 4. So I get a minus 4. Then I take a and square it. Well, a squared is just a squared. And I add a times b. So a times 4 is 4a. And then I take b and square it. Well, b is 4 and 4 squared is 16. You'll never be able to go farther if you pulled out a GCF from the beginning. So do not try and factor that trinomial. You would be done at that point. Number 5, 6x squared minus x minus 15. We need a factor. We look for a GCF and there's nothing in common between all three terms. We do have three terms, so going down the list, it's not the C method because the number in front of x squared is not 1. The number in front of x squared is a 6. There's lots of different ways to show how to do the AC method. I show it where I do not do a guessing game. I go through the process of actually turning it into 4 terms and factor by grouping. If you know other ways, feel free to factor this a different way. But I am going to show where I change it into factor by grouping. So because this is the AC method, and again that's because the number in front of x squared is not 1, I'm going to start off by multiplying a times c. So 6 times a negative 15 is a negative 90. And when I have negative 90, I then find the factors of negative 90 that add up to my b term. So it's a lot like the C method, but we can't jump to our answer. We start off by multiplying a times c, then we find the factors of that add up to b. Well, b would be a negative 1. It's a number in front of my x. So what are the factors of negative 90 that would add up to negative 1? They would be a positive 9 and a negative 10. When I multiply those two, I get a negative 90, but if I add 9 and negative 10, I get a negative 1. So make sure your signs are correct. There's only one factor that will work. So I'd love to jump to my answer, but I cannot. What I do is I take these factors that I found that work and I replace the b term. So I break the b term up into 2 separate terms. So everything else still stays the same. I have a 6x squared. Instead of a negative x, I'm going to have a positive 9x, so plus 9x, and a minus 10x. If I put those back together, I get that negative x. So I'm not changing the problem. And I still have that minus 15. So make sure you understand what I just did there. I broke up my middle term into 9 and a negative 10. At this point, we have 4 terms. So just like the previous problem, with 4 terms, I factor by grouping. So I'll group the first 2 and the last 2. What's in common between a 6x squared and a 9x is a 3x. So when I pull out a 3x, I'm left with 2x plus 3. Minus, there's that minus again. I'm going to pull out a 5 because that's what's in common between a 10x and a 15. And I'm left with 2x plus 3. Again, why did that sign change? Because I took out a negative. You can multiply back in and make sure you got back what you started with. And you'll see that it is the same. At this point, I look to see what's in parentheses. If what's in parentheses is not the same, I've done something wrong. But they are the same, so I'll continue on. I'll pull out the GCF of a 2x plus 3, and in parentheses I'll write what's left, which is the 3x minus 5. Again, order does not matter. You could have the 3x minus 5 first and the 2x plus 3 second. If you want to multiply that all back out, you can check your answers. You should get back 6x squared minus x minus 15. So I would definitely think about checking your answers. Number 6, 12x to the fourth minus 62x cubed plus 70x squared. Looking for a GCF first, and we do see there's a 2 in common with all the numbers and an x squared. So I'm going to take out a 2x squared, and in parentheses I'm going to write what's left. From a 12 I have a 6x squared left, minus 62 divided by 2 is 31. I took out x squared, so I'm left with x, plus 70 divided by 2 is 35. I took out an x squared, so there's no x squareds left. So there's going to be a GCF, and now when we look at inside parentheses, we see it's the AC method because the number in front of x squared is not 1. So I'm going to let you continue on with the AC method, but I'll start you off. 6 times 35 is 210. And what do we have to do? We have to find the factors of 210 that add up to a negative 31. You might want to grab a calculator and do 210 divided by 2 divided by 3 and just start listing all the different factors. The factors that actually work are negative 21 times a negative 10. When I multiply two negatives, I get a positive, but if I take the negative 21 and I add a negative 10, I get the negative 31. So what do we do with that 2x squared? Well, I suggest just bringing it down, because that is going to be part of your answer, and not worry about keeping it throughout the whole problem. So bring down the 2x squared, now do the AC method. So we'd have 6x squared minus 21x minus 10x plus 35. Again, we take those factors that work and replace the b term, breaking it up into two separate terms. So I'm going to let you finish the factor by grouping. Again, just group the first two, pull out what's in common. Group the second two, pull out what's in common. So my final answer is 2x squared, and then a 2x minus 7, and then times 3x minus 5. Number 7, 25y to the 7th minus 16y to the 5th. First thing we look for is a GCF. Now, between a 25 and a 16, there's nothing common. But between a y to the 7th and a y to the 5th, y to the 5th is in common. So I'll pull out y to the 5th, and we're left with 25 y squared minus 16. Now, 25y squared minus 16 is a binomial, so we have two terms, and it's going to be a difference of squares. So y to the 5th will stay out in front, and I'll use the difference of squares formula. 25y squared comes from 5y, 16 comes from 4, so plus 4, and then 5y minus 4. So my final answer is y to the 5th, and then in parentheses 5y plus 4, 5y minus 4. Number 8. 10x cubed plus 1,250 y cubed. First thing we need to look for is a GCF. Between an x cubed and a y cubed, nothing's in common, but between a 10 and a 1,250, there's a 10 in common. So I'll pull out a 10. When I pull out a 10, I'm left with x cubed plus 125 y cubed. Since we do have a GCF of a 10, again, you could keep that throughout the whole problem, or just bring it down and know that in your answer blank you're going to have a 10 as part of your answer. Let's look at x cubed plus 125 y cubed. Two terms. It's either a difference of squares, difference of cube, or sum of cubes. Because we have a plus sign, that would be our sum of cubes. So the formula for a cubed plus b cubed is going to be a plus b. Then we take a squared minus ab plus b squared. Make sure you memorize these formulas. You can't get to the answer any other way. So now we have to figure out what is the a and the b. It's the things that are being cubed. So what is being cubed that's going to give me an x cubed is an x, because x times x times x is x cubed. What is being cubed that's going to give me a 125y cubed is a 5y, because 5y times 5y times 5y is 125y cubed. So plugging this into our formula, the a is x and the b is 5y, so x plus 5y. Then we take x and square it, so we get x squared, minus a times b, so x times 5y. So what is x times 5y? It's just 5xy. Plus, then we have to take b and square it, where b is 5y, but I need to square it. So I have to square the 5, which is 25, and y times y is also y squared. So b squared is actually 25y squared. You'll never be able to go farther on that if you've already taken out the GCF. So let's finish up our answer. The 10 from the GCF, and then x plus 5y, and then parentheses x squared minus 5xy plus 25y squared. Number 9, 5a squared plus 26a minus 24. Looking for GCF, there is none. There are 3 terms, so we're looking to see if it's a C method, the AC method, or perfect squares. Because the number in front of a squared is 5, we know that it's the AC method. So I'm going to let you do the AC method. I will give you the final answer, and the final answer would be 5a minus 4 times a plus 6. So make sure you can do that AC method. Number 10, 54 minus 2b cubed. First thing we look for is a GCF. There is a 2 in common, or if you want, you could pull out a negative 2, because some students want that variable to be first. So if you just pull out a 2, you're left with 27 minus b cubed. We'll see that we have 2 terms. It's a difference of squares, so follow the cubes formula. However, if you pull out a negative 2, that flips the binomial, so we get b cubed minus 27. So you could either pull out a 2 and factor it as is, or pull out a negative 2. It flips and then factor as is. So either way, you're going to get an answer that kind of looks a little bit different, but it actually is truly the same answer. If you don't flip it, you end up with 2 parentheses, 3 minus b, then 9 plus 3b plus b squared. So if you don't want to take out the negative and you just want to take out the positive 2, that would be the answer that you would end up with. If you do take out the negative 2, you're going to end up with a b minus 3, then b squared plus 3b plus 9. So either answer is correct. It just depends on how you want to work out the problem.